I hope the handwriting is clear for everyone. Now, what is motion actually? If I just discuss with you people, what do you mean by motion? That means a body. Remember one thing. Let me tell you a story. Once upon a time, there was an object. Once upon a time, there was an object, and sometimes it was in a rest condition, sometimes it was in motion. Right? Here and word motion comes. What do you mean by motion? Motion is a change in position with respect to time. Right? Change in position. Motion is change in position with respect to time. Right? That means at every second it is changing its position. That means the body is in motion. Suppose you are riding a bicycle, or you are just driving a car, or if you just walking on a road, or if you just running on a road, that means you are in motion because you are changing your position every time. Sometimes I will see you at a position, sometimes I will see you at another position. Let me tell you about the story deeply. That means this is a car. Okay, actually I am very bad in drawing, you guys know already that. Now this is the car. Sometimes I see that car at this position, sometimes I see that car at this position. Right, at 2 second I just see that car at this position, and at 4 second I just see that car at this position. That means between this time interval the car has changed its position. Right, that means the car is in motion. So what is the story about rest? What do you mean by rest condition? Rest condition means here the a rest condition means a body will not move, will not change in position with respect to time. We know the definition of motion, that is it is the change in position with respect to time. When an object will do that, then only the object will be in motion. Right, now in this case what I mean by rest condition, that means suppose there is a block, there is a wooden block which is kept on a surface. Right, there is a wooden block which having a mass of 5 kg which is kept on a surface. That means with respect to time the object is not changing its position. Right, if I am talking about the wooden block which having a mass of 5 kg, the object is not changing its position with respect to time. That means the object is fixed at a particular point. This is about its rest condition. That means when an object will not change its position with respect to time, then the object will said to be in a rest condition. That means the definition, that means if it is asked that when an object should be in rest, you should tell that an object if an object is not changing, it's not changing its position, is not changing its position with respect to time, with respect to time, then the object should be at rest. Right, then the object should be at rest. The object should be at rest. Right, so two of the definitions we have just got. Right, one is about the rest condition, another is about a motion. Right, what do you mean by rest condition? If an object is not changing its position with respect to time, that means the object is in at a rest position. And if the object is changing its position with respect to time, then you can tell that it is in motion. Right, now this is the story about rest and motion. Now let me tell about the story behind rest and motion. Right, the second part of the story. Right, that is of story 2, part 2 is actually. So an object may be in rest, may be in motion, right? Suppose if we assume that the object is at rest position, that then when the object will change its position, that means when the object will change its state. Actually, what the story I have just told you, it is about the states of an object. States of an object. That how many states of an object have? An object have two states. One is rest, another is motion. So when an object is at rest, when an object is at rest and it want to change itself to motion, then what should be applied to change the state of an object, right? What should be applied? If an object is initially at a rest position, suppose, I hope that everyone have its pet. I think some of the girls have pet itself. Someone have a dog. Someone have a bird as a pet, right? So when you just go closer to that of your pet, it just comes to you, or it just try to move itself, right? So in that case, when you will apply some unbalanced force to an object, when you will apply some unbalanced force to an object, then only the object will change its position. That means if we apply some force on an object which is already in rest, and if that force is of unbalanced type, right, if that force is of unbalanced type, then only the object will change its state and it will be in motion. The object will be in motion, that will, it will move with a velocity of v meter per second. Initially it was having a velocity of 0, but when we have applied an unbalanced force, then we have seen that it is in motion, right? Suppose in the class, when we were at your age, we just played some game as pen fight, right? Two of the pens were there, and on one pen we just apply the force, and then the two pens collide. I hope that you people also play that when you are in the school. So in that pen fight, what happens? When we apply some unbalanced force, then only the pen moves, right? That means the pen was initially at rest, and after applying that unbalanced force, the pen is in motion. That means it start moving with a velocity of v meter per second. So this is the change in state. There is a case 1, right? This is the case 1. What is about the case 2? Now if we assume that we are riding a bicycle, okay, let's suppose I am riding a bicycle, that's me, okay, that's me, and I'm just actually it's a box. I don't know that how to make a bicycle. Let's suppose assume that I am having a car and I am just driving that car like that. So in that case, if I am driving that car, that means it is having some velocity of v meter per second, right? It is having some velocity of v meter per second. That means the car is in motion, right? The car is in motion, right? So if I want to stop that car, what I should apply? If I want to stop that car, what I should apply? I should apply the brake, right? Brake means it's a one type of unbalanced force. Then after applying some unbalanced force, I can stop that car. That means the car was at motion, and after applying that unbalanced force, it will be at rest. That means the velocity will be equals to 0 now, right? That's me also. So initially my car was moving with a velocity of v meter per second, but after applying that unbalanced force, my car just stopped, right? That means the velocity is equals to 0, right? So once upon a time there were two states of an object, one is rest, another is motion. To change the state of an object, we should apply some unbalanced force, right? Now in the first case, what we have seen, when we had applied some unbalanced force, then the state of an object, changes from rest to motion. And when we had applied an unbalanced force to an object who was already in motion, it changed state from motion to rest. Right? Up to that, whether everything is clear, it is about a story of rest and motion. At first we have understood what is rest, what is motion. Then we have understood how to change the state, how to change from a rest to motion or from motion to rest. We have seen that we have to apply some unbalanced force to change the state of it, right? So, if I ask you what do you mean by motion, that means if an object is changing its position with respect to time, then only I can say it is about a motion, right? That means a moving car, a moving horse, a moving bicycle. Even if I am start working, that means I am in motion, right? So if you want to change the state of an object, you have to apply some unbalanced force, right? That you can see here. Now let's move to the next topic, right? That means some of the quantities that helps us to express the motion of an object, because we are in the chapter of motion, right? We are in the chapter of motion. So what are the quantities that will help us to express the motion of an object? How to express the motion? That means we should know that if an object is in motion, that means if this is the car, this is the small car actually. It's not a car, it's about a truck, right? So it is moving with a velocity of v meter per second. So how much distance it is traveling? We should know that also. If the truck is moving with a velocity of v meter per second, how much a distance is traveled, that I should know, as well as the displacement also, right? So how to know the distance and displacement? Here we have got a new term that is equals to velocity also. So let me tell you one by one. What is the distance traveled? What is the distance traveled? That means the definition of distance. That means the path traveled by an object, that is the distance traveled. That means if I am talking about that truck, if the truck is traveling in this direction and he is traveling a distance of s, that means the distance traveled, that is equals to s here. That means what is distance traveled? It is the path traveled by an object. It is the path traveled by an object, right? By the object, I can say like that, as you can see in this diagram. Even I can give you another example also, right? What is that example? That is, if suppose this is the ball, right? This is a football actually, and if this ball is moving with a velocity of 2 meter per second, that means it's rolling, 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 and at this point it comes, right? So what is the distance traveled? Suppose if the distance traveled, that is equals to 4 meter with a velocity of 2 meter per second, right? In this case, so the unit of distance traveled is known as meter. If I talk about the unit of distance traveled, it has two units actually. Two units, one is SI, another is CGS. That means in SI we have the units as meter or kilometer. In CGS we have only centimeter. Remember that. In CGS we have only centimeter. So what is the unit of distance traveled? In SI we can say that the distance traveled is 4 kilometer, 6 kilometer, or 4 meter, 6 meter, whatever. For long distance we use kilometer, and for very short distances we use meter or centimeter. Okay, so now in this case we have got the definition of distance travel as well as the CGS and SI unit of distance travel as well, right? So in your mind one thing should come, sir, you was just telling about a story of rest and motion, but now you have introduced a new character, that is of distance travel. So if the path traveled by an object is 4 kilometer or 6 kilometer or 10 kilometer, so the object is moving with some velocity or with some speed, right? So what is the difference between speed and velocity? And what thing we know? We know what is the basic difference between distance traveled and the displacement as well, right? We had already covered that. You guys have already covered that, right? So distance traveled we have just come to know here. But what is about displacement? What I mean by displacement? Let me tell you another story of me. What is about the story? Let's see. So displacement. I am not telling you the definition of displacement at this time. Let me draw something over here. This is my home and this is another tree, okay? In my childhood actually my drawing teacher has just make me learn to draw only coconut trees. So that's why I always draw only coconut trees. Okay. So in this case, how to find out the displacement? What is mean by displacement? Let me tell you with the help of these coconut trees. Right? I'm not able to draw very much here. Let me assume that these are the coconut trees. Okay. Now, in this case, I am at this position. At a particular time, I am at this position, and the distance from this coconut tree to my house, that is equals to 3 meter. And the distance from my house to that coconut tree, that is of 4 meter. So what I had done, I just start traveling from this point. This is the first coconut tree. I just start traveling in this direction. I just reach my home. Okay, I just reach my home, then I start traveling in this direction and I reach to that point. Suppose this is the point A, my home is the point B, and this is the point C. Initially I start traveling from A to B, then I move from B to C, right? Actually my home has also doors and windows as well. Actually I have not made it, but it had. So in this case, this is the initial point, right? This is the initial point or initial position, I can say, and this is my final position, right? This is my final position. So there is some minimum distance between the initial position and final position. Sorry, there is some minimum distance between initial position and final position, right? That means I am talking about the distance AC. So the minimum distance between the initial position and the final position here. The minimum distance between initial position and final position, that means I am talking about that distance. I am talking about that distance. Okay. So in this case, the displacement is the distance between or the path difference between the initial position and the final position. What is the path difference between the initial position and the final position? That is known as a displacement. Displacement and distance traveled both are two different quantities, but some of the things are similar, right? Because in this case what I am doing, I am just traveling from point A to point B, Then I move from point B to point C. So what is the displacement of me? That is the minimum distance between initial position and final position. That means the displacement that is equals to AC, right? I can say like that, that is the displacement in this case, that is equals to AC, right? So in this case, if you just find out with the help of Pythagoras theorem, you will see that the displacement in this case, that is equals to 5 meter. In this case, I am just giving you that example, right? Remember one thing, in this case, the displacement, that is the minimum distance. Displacement, let me give you the definition of that also. It is the minimum distance, it is the minimum distance between initial and final position. Between initial and final position, right? It is the minimum distance between initial and final position. In this case, the displacement that is equals to 5 meter, right? So there are more stories, lots of stories are there. Physics is nothing but a story. Okay, you just have to remember the stories, that's all of the problems will be easy. Okay, that's good. Now let's move. We had just covered the topic displacement. Now if I talk about the SI and CGS unit of it, the SI and CGS unit of displacement, that is same for distance traveled, right? If you just see that here, the unit of distance travel, that is the SI unit is meter or kilometer. In the case of displacement also, that is same. Let me write it down. Now if I talk about the unit of displacement, in this case this should be a straight line. Yeah. Oh. Now unit of displacement, what are the two units it has? That is of the SI unit and the CGS unit. The SI unit of displacement, that should be equals to, it is meter or kilometer, and the CGS unit, that is equals to centimeter. You guys should ask that, so why it is like that? SI unit of distance traveled and displacement both are same, because displacement is a one type of distance traveled. Like you are covering some distance, that means the SI unit should be meter or kilometer, and the CGS unit for very small distance, that is equals to centimeter, right? So what is the difference between distance and displacement? That kind of question can be asked in exam, right? They write down two difference between distance and displacement. So one another thing you should know, that's very secret thing, right? That is not in your standard, that means not in ninth standard. Oh, sorry, the whiteboard just very much zoomed. Let me reduce the zoom level here. Okay, I hope now it is visible. Okay, now one secret thing between distance traveled and displacement. What is that secret? Distance traveled is a one type of scalar quantity. What I mean by scalar quantity? Distance traveled is a scalar quantity because it has only the magnitude. It does not have any direction, right? That means if you suppose assume that you are at your home, okay, and you are just come outside of your home and you just start traveling 4 kilometer to the left of you, then again travel 10 kilometer to the right of you, and lot of distance you have just traveled, but it does not have any particular direction, right? It does not have any particular direction of distance traveled. I can't express the distance traveled with respect to direction. So, as the distance traveled is not having any particular direction, that's why the distance traveled is a scalar quantity, because it just having the magnitude, right? So, in this case, let me write it down here with a star mark because it is important. That is, distance traveled is a scalar quantity. Distance traveled is a scalar quantity. And what is about displacement? I have told that distance traveled is a scalar quantity because it is just having the magnitude and it do not have any direction. And if I talk about displacement, displacement is not a scalar quantity, right? So what is it? Displacement is having any particular direction. What is that direction? That means, as you can see in this diagram, that displacement is measured from initial position and final position, the minimum distance between initial and final position. So the direction is like that, it should not be any other direction, right? So in this case, as displacement is having the magnitude as well as the direction, let me write it down, it will help you. Displacement is having a magnitude as well as a particular direction. As well as a particular direction, so it's a vector quantity. So it is a vector quantity, right? You guys will understand about scalar and vector in class 11 as well. There are a lot of things to learn about scalar and vector, right? So we have understand what is about a displacement, and it is also a vector quantity because it is having magnitude as well as a particular direction. So I hope you guys are able to differentiate between distance and displacement. The first thing to write down a difference, that is, you have to write down the definition of these two quantities. So your homework question, one homework question, that is, find out the difference, find out the difference between, this is the shortcut of between distance and displacement, between distance and displacement. Don't copy from anywhere, just understand. I will just share that notes, whatever I'm just writing over here, I will just share with your group. Okay, so collect all of the information that I have shared in this whiteboard and then try to differentiate between these two quantities. I just need 2 to 3 difference. Okay, lots of differences I don't want, 2 to 3 difference is enough. Okay, so now let's move to another topic, that is, what is speed? If I am traveling from that coconut tree to my home, that means I should have some velocity or I should have some speed. So I am talking two things. One is speed, another is velocity. So these are two different things. So how they are different? Let's see. Let me just slide it down. Now we have a new whiteboard over here. Now what is speed here? That involves another story. Sometimes we say that the speed of my bicycle is very good, the speed of your bicycle is very less. What is speed? Remember that one. How much distance you are traveling, how much distance you are traveling in a particular time, how much distance you are traveling in a particular time, that is equals to the speed of your, right? That means if I am talking about a car, this is the car. Uh-oh, I have to draw a truck over here. The truck is moving in this direction, and it has covered a distance of 2 kilometer. It has covered a distance of 2 kilometer in 1 hour. It's a very less speed, na? It has traveled 2 kilometer in 1 hour. That means the speed should be the distance traveled divided by the time taken. Remember that speed, that is equals to the ratio of distance traveled divided by the time taken. So in this case, what is the distance traveled? That is equals to 2 kilometer. And what is the time taken? That is equals to 1 hour. So what is the speed over here? That is equals to 2 kilometer per hour. If I talk about the definition of speed, the definition, that is the distance traveled by an object in a particular time, that is equals to the speed of an object. So in this case, the speed, that is equals to 2 kilometer per hour, right? So let's see whether you people are able to solve or not, right? Let me have a car. This is actually a car. It's like a, whatever the drawing of car I'm just drawing over here, it's like a spaceship, like, so one type of spaceship, it's not a car. Okay, now if the car has moved, the car has covered a distance of 40 kilometer. Car has covered the distance of 40 kilometer in 1 hour. So what is the speed of the car? Who can tell me the answer? The car has covered a distance of 40 kilometer in 1 hour. So what should be the speed of the car? Who can tell me that? Let's see, girls. You guys can do it. What should be the answer? Everyone. As I have explained in the previous, that's very good. 40 kilometer per hour, right? In the previous case, as we have explained, that the truck was traveling 2 kilometer in 1 hour. That means the speed of the truck, that is of 2 kilometer per hour. In this case also, as my car is traveling a distance of 40 kilometer in 1 hour, that means the speed of my car, that is equals to the distance traveled, that is of 40 kilometer, divided by the time taken, that is equals to 40 kilometer per hour, right? So in this case, the speed is expressed. So as you can see in the formula of speed, let me tell you that speed can be the expression that I have used here. That kind of expression can be formulated. That speed equals to V. V equals to the distance traveled divided by time taken. Here V equals to the speed, S is equals to the distance traveled, S is equals to the distance traveled, and T is equals to the time taken, right? T is equals to the time taken. So in this way, the formula of speed we can find out. That is V equals to S by T. Even I can do one thing, that S equals to V multiplied by T. V should be written like that. In this case, V multiplied by T. In this formula, you can find out the distance traveled as well. right? Now, whatever the expressions we have just used here, speed equals to distance by time. So distance is a one type of scalar quantity. Am I correct? Distance is a one type of scalar quantity. Time is also a scalar quantity. So here speed will be a scalar quantity. Remember that speed is a scalar quantity, as distance traveled is a one type of scalar quantity. Time is already a scalar quantity. Therefore, speed is a one type of scalar quantity. Let me write it down here. I am just writing down over here. Now, speed is a scalar quantity. Remember that expressions, okay? Now, if I just give you some example and you have to find out the speed, let's see you guys are capable or not. I hope you guys can do that. That means one question can be asked in your exam. That is, if a car is traveling a distance of 30 kilometer, if a car is traveling a distance of 30 kilometer in 5 hours, find the speed. Find the speed of the car. Just find out that question, the answer of that question. If a car, at first write down that question. If a car is traveling a distance of 30 kilometer in 5 hours, then find out the speed of the car. Let's see whether you guys are able to find out or not. Yes, the answer is 6 kilometer per hour. That's very good, girls. Both of you. Now, in this case, the speed of that car, that is equals to 6 kilometer per hour. Now, I hope the rest of the girls have also found that, right? The answer is very easy in this case. Now, let me help you out, right? Now, in this case, how to solve a numerical problem? At first, draw or collect all of the informations. Now, the distance traveled, that is equals to 30 kilometer, and the time, that is equals to 5 hour. Distance traveled, that is of 30 kilometer, and the time, that is of 5 hour. So what can I say? The speed, that should be equals to, what should be the speed? That is of what the distance traveled and what the time taken, right? So speed equals to distance traveled divided by time taken. So in this case it should be 30 by 5, that is of 6 kilometer per hour, right? Okay, now that's very good. Now remember one thing, we'll start discussing the distance and displacement again, but let me tell you another physical quantity. What is that? We have understood about speed. Now let me tell about the concept of velocity. What I mean by velocity? What is velocity? Right? What is velocity? In this case, if I talk about that, velocity is same like speed, but velocity is a different from the concept of speed, because velocity can be expressed as the displacement. It can be expressed as the displacement divided by time taken, right? Remember that velocity can be expressed as the displacement divided by the time taken. So in this case, the distance traveled and displacement both are different. That's why the velocity is different. Initially, what we know, that speed is a one kind of scalar quantity, but in the case of velocity, you can see the expression that is of displacement by time taken. That means velocity is not a scalar quantity. Velocity is a vector quantity because it is having the direction as well as the magnitude. Velocity is a vector quantity. Remember that velocity is a vector quantity because it is the ratio of displacement and time taken. Displacement itself is a vector quantity. That's why the velocity is a vector quantity, because the direction of displacement will be the direction for velocity. Okay, so let me tell about some secrets of displacement and distance travel. This is also the secret of speed velocity as well. Now the next concept, that is, if I tell about the definition of velocity, that means it is, velocity means whatever the displacement is done by an object, and for that displacement whatever the time is taken, velocity can be expressed as the ratio of these two. That means the ratio of displacement and time taken. In this case, what can be the speed of what can be the unit of speed and velocity? Let me tell about the units of both of the quantities. For the speed, what should be the SI unit and CGS unit? Let me tell about that. For the speed, the SI unit should be meter per second. Let me write it down with a different thing. I hope it will be better to make you people understood. The SI unit of speed, that should be meter per second, and the CGS unit, that should be centimeter per second, right? Even for long distance, the speed can be used, that is of kilometer per hour as well, right? Kilometer per hour is also used for the speed which where the value of the speed is very greater. Suppose if I talk about the speed of a car, or if I talk about the speed of a truck, then the speed of that is of 40 kilometer per hour, 20 kilometer per hour, because a truck can travel some kilometer in a particular time. So that's why the speed of uh, a heavy vehicle, or for long distance traveling, we use the speed as kilometer per hour, which is a SI unit. Remember that. Okay, now if I talk about the units of velocity, so what is the SI and CGS unit? SI and CGS unit, if I talk about that, the SI unit of velocity is meter per second or kilometer per hour, and CGS unit is centimeter per second. That means the CGS and SI unit for speed and velocity both are same, right? The CGS and SI unit for speed and velocity both are same, right? But both are different quantities. Now what is your homework? That is, the homework question is same that of previous. That means you have to find out the difference between speed and velocity. Let me write down the homework question. The homework question should be, find the difference find the difference between speed and velocity. Find the difference between speed and velocity. I hope whatever the things you had covered at the time of motion, that memories are reactivated. Na? Speed and velocity, that kind of expression you have just got at the time of reading that chapters. Now, what are the secrets of all these physical quantities? Let me tell about that story also. Now, what is about the secret? That means if I'm talking about a circular path and I am at this point A, I'm at this point A and I start traveling in this direction. Okay, there is a ground and I start walking in this direction and finally I reach at point A again. For a circular path, I just start traveling from point A and I just move in that directions that I have drawn over here and I just come back at point A. That means in this case, for a circular path, for a circular path, if I have covered that amount of distance and the initial and final position both are same, that is the A point. I had started my journey from point A and I have reached the same point, right? That means in this case, as the initial position and the final position both are same, that means my displacement is equals to 0, right? That means the displacement in this case, that is equals to 0. For a complete circular path, the displacement, that is equals to 0. Here a word complete should be introduced here. For a complete circular path, the displacement, that is equals to 0, right? Now, whether the distance traveled is also 0? No, the distance traveled for a circular path is not equals to 0. Because why it is like that? For a circular path, displacement depends on the initial and the final position. Remember that. What the reason that the displacement is equals to 0? Let me write it down, thus you guys do not forget that one. Why it is like that? That the displacement for a circular path is 0 but the distance traveled is not 0. Okay, the class will be over within 1 to 2 minutes. Don't worry for that. Displacement is equals to 0 because in this case the initial and the final position both are same. Initial and final position both are same, right? That's why the displacement is equals to 0. Distance traveled is not equals to 0 because you are covering some distance now. At the time of moving in a circular path, you are covering some distance. That means the distance traveled not equals to 0 because distance traveled distance traveled does not depend on initial and final position. On initial and final position, distance traveled will not depend on initial and final position. So that's why the distance traveled, that is not 0 in a circular path, but the displacement will be 0 for a circular path. Okay. So at this point of time, I have to finish the class because the time is over. So keep revising all of the things. Thank you so much for the class. Keep practicing. Okay. Make a schedule of yourself and keep practicing at your home. And let me take the attendance now.